Well, welcome to everyone who's joining us. We're going to get started in just about a minute. Thank you for joining us for day 5 of Stormwater Awareness Week. This is the final day, and we have some great workshops lined up for you today. Ranger and Roger have a fantastic presentation planned for you guys. So it is 9 o'clock. I'm going to hand it over to these gentlemen so they have the full hour to present. So Roger and Ranger, do you want to introduce yourselves? And thank you for being our presenters today.
All right. Thank you very much, Rebecca. My name is Roger Sutherland. I'm a water resources engineer. I got my own little company. I was principal for 12 years with Pacific Water Resources out of Portland, Oregon. I've got about 52 years of experience in water resources engineering. And my entire career, I have been interested in street sweeping. I started my computer modeling aspect back at the University of Maryland back in 1973. So you can see how old I am. Next.
And I'm Ranger Kidwell Ross. I started into the power sweeping industry because I was interested in water. This very topic we'll be talking about today. I started in 1988 with the first newsletter for power sweeping. I learned that many public works directors thought they were still sweeping for horse poop rather than clutch plates and brake linings and other items. And so in the early 90s, I founded the first magazine for power sweeping, American Sweeper Magazine. 19 years ago, I moved that to completely online at worldsweeper.com. We've covered, I believe it's 23 different countries and different sweeping aspects. I've gone to about a dozen of those and taught sweeping and learned about what's going on in other worlds. And we have today, Roger will talk about the history of sweeping and coming into current, and I'll talk about where we are today and where we're headed in the near future.
All right. Thank you very much. I do want to remind everyone that this presentation kicks off 3 hours worth of discussion regarding street sweeping. So if street sweeping is something of interest to you, and it really should be of interest to every person in the stormwater business, then stay tuned. Following me, there's a presentation by Chris Minton, Ryan Parks with Larry Walker and Associates, along with John Ball of the city of Los Angeles. They're going to talk about a couple of Southern California case histories where street sweeping was investigated. And then following that at 11, we're going to hear from the deputy director of the Southern California Coastal Water Resource Project. They've been working on a street sweeping study for about 18 months, and I think there's still more to be done, but he's going to give you the current results and update you with the status. But right now, let's talk about enhanced street sweeping. Like Ranger said, in the beginning, and if you look at this photograph, I think Chicago around the turn of the century, even though it was invented by Benjamin Franklin, is that street sweeping was really done to clean up horse poop and waste products. And the emphasis was never on water quality, was simply on picking up horse poop. So anyways, in the early 1980s, the U.S. EPA program dedicated $30 million to study all of the various types of best management practices that were being discussed, because this whole thing was in its infancy. The Clean Water Act had just been passed, 8 years prior to that. So street sweeping was included in that list. In fact, there was 10 sites located in 4 states: North Carolina, Illinois, Washington, and Wisconsin. And the way this worked, it was a paired basin analysis where they were sweeping one, where they weren't sweeping the other, and then they go out and sample the stormwater when it occurs with automatic samplers, and they end up with event mean concentrations for each of these different storms, and they compared to swept, unswept. And those are the 5 pollutants they focused on. But you know what? It was the unexplained negative results from 2 sites in North Carolina and 1 in Wisconsin that resulted In the conclusion, and I must read it to you because it was an albatross across street sweeping's neck for decades, street sweeping is generally ineffective as a technique for improving the quality of urban runoff. Now, they arrived at this conclusion despite the fact that the data clearly showed EMC decreases in 34 of the 50 site pollutant investigations. In fact, the whole thing of being statistically insignificant has been an albatross that's been plaguing the industry ever since. But you know, there's good news. There's good news. And the good news is that today's mechanical street sweepers are much better than what they were many years ago. And I got silly thing going off here. All right, sorry about that. And in fact, their pickup performance has doubled, if even tripled, from the machines that were being tested by the NERP. And in fact, I did test one mechanical, a couple air sweepers, but one mechanical sweeper in 2008 for the Elgin sweeper company in Elgin, Illinois. And we determined that this Elgin Eagle, which is the mechanical machine, but it did have a shrouded gutter broom for fugitive dust control, which I think helped immensely. We had a pickup efficiency as high as 86.4%. But in that testing procedure, which will be discussed a little bit later, we also determined that if we use water spray for dust suppression, that we reduce the fine pickup performance, and we're talking 250 microns or less, by 20%. Excuse me, yeah, 250 or less. So here's the issue. Why can't we figure out how to sweep dry and not wet? But here, we've even got better news, because the modern air sweepers that are available, that were not available during the NERP testing, they now have the ability to pick up pollutants and remove them from stormwater at a greater way than any other tests that or any sweepers we've tested. In fact, the 250 micron, we talk about it because it's the most bioavailable mobile fraction, and we have actually documented pickup performances in single tests as much as 95% with regenerative air machines. So, you know, there's been a lot of studies that have been done on street sweeping over the years, and that's been the difficulty because of the varying conclusions. And part of that problem is we didn't realize that, you know what? I heard a long time ago, sometimes it's hard to believe that no two snowflakes are the same. Well, I'm telling you, no two small urban catchments are the same. And it's the differences in these catchments that got in the way with the results of these studies. But I want to focus on one that occurred in the city of San Diego. That's in Southern California, obviously. It was called the Targeted Aggressive Street Sweeping Pilot Study. They did it in 2010. And I was very impressed with it because they recognized the difficulty of paired basin and decided, okay, we're going to sweep one side of a street and not sweep the other side. And when it rains, we're going to run out there with a beaker or whatever, and we're going to get the water as it flows from the gutter into the catch basin. We're not going to let it go down the pipe and try to catch it somewhere else. That's where we're going to do it. And lo and behold, they caught 3 storms. You see the data there. What did they find? Total suspended solids reduced by 70% by a mechanical broom sweeper and 85% by a vacuum. Now, they didn't even test a regenerative air. If they had, I think they would have got even higher results, well into the 90s. But when you start looking at other pollutants, and they focused on metals, you can see that there is a disparity in terms of the ability of the broom sweeper to reduce pollution versus the vacuum. And this would even be a greater disparity if they had tested a regenerative air. So let's now talk about the study that changed everything. In 2019, John Sansaloni with the University of Florida, in association with the Florida Stormwater Association, and 12 to 14 MS4s throughout the state of Florida, basically published the results of their 12-year, $2+ million effort. And they concluded that street sweeping was by far the best BMP, up to almost 7 times more cost effective than the next BMP. And they focused on nitrogen and phosphorus recovery, which clearly are very difficult pollutants to address. Now, the way the study worked is they went out and just measured the amount of material being captured by all of the range of available BMPs, from sweeping, catch basin cleaning, and then a variety of structural end of the pipe measures. And then they costed what it was to capture a pound of nitrogen or a pound of phosphorus for each of the recovery methods. Sweeping was the lowest cost per pound. Catch basin cleaning was second in all instances. Let's look at some of the data. And now, when we talk about nitrogen, look at that, $189 a pound via street sweeping. It's almost 10 times that much, at least 8 times that much for catch basin cleaning. And then that's the median of all of the best management, the structural gadgets and widgets that we put into the system to try to remove pollutants and solids. And you can see that that's even twice catch basin cleaning. So let's look at phosphorus. Phosphorus is perhaps one of the most, if not the most difficult. I can only think of bacteria as more difficult, a pollutant to address in stormwater. And here we got the street sweeper picking it up at $294 a pound. Catch basin is clearly maybe 6 times more at somewhere around $18.94. And then, of course, look at how much it costs to pick it up by the median of all of the various end of pipe treatments. And what's really interesting is, if we go to the next slide, that is, particle recovery of particulate material matters. And this is John's words, by the way, John Sansaloni, proving that street dirt pickup recovery also matters. In fact, the Florida studies found that street sweeping was the most economical and dominant practice that MS boards could implement and optimize in order to maximize nutrient and particulate material recovery benefits. And folks, if they had studied metals, if they had studied toxics, they would have studied any other pollutant, but maybe bacteria, they would have arrived at the same results. And what's really interesting is that here they are doing this study using street sweepers, and yet they, like so many people in the country and people in stormwater, know so little about street sweeping that they didn't know they should have separated the broom and the air sweeper data. And I believe if they did that, we would see even more dramatic results, and that the air sweepers would be even cheaper to remove a pound of phosphorus or nitrogen. But here's the most important thing. This statement changes everything. The study showed conclusively that we had a reduction of, okay, we switched the slides, but it was statistically determinate at 95% confidence interval when they combine all 14 MS4s for particulate material, total nitrogen, total phosphorus. That is the conclusion that I expected that we would eventually hear. And I'm glad I'm still alive to hear it. So let's now talk about what it is that we want to talk about here today. Okay, so if you want to maximize the environmental value of a street sweeping effort, create an enhanced sweeping program. What is an enhanced sweeping program? It's a program specifically designed to focus on the maximum reduction of pollutants and microplastics traditionally found in stormwater runoff. We're talking particulate material, spended solids, and all the contaminants associated with it. By the way, both of those things can actually have a very negative effect on urban air quality. So the ability of a street sweeper to pick up accumulated dirt and contaminants, which we call street dirt, is affected by a number of things. And we're going to touch on each one of these, because if you want an enhanced sweeping program, you need to understand sweeping interaction and how it interacts with the accumulation and wash off of street dirt, which was identified in 1972 by Sator and Boyd as the primary source of pollution in stormwater in the urban environment. So let's talk about pavement conditions. Pavement conditions are extremely, and also barriers. Let's talk about that. Condition and barriers. Okay. It's pretty clear that we have difficulty, street sweepers have difficulty in picking up dirt on pavement classified as poor or fair. This is due to cracks and deep depressions where the dirt can accumulate and basically hide. Uneven surfaces make it difficult, okay, especially for the newer air machines that use air and not brooms to pick up material, so regenerative or vacuum. So here's the thing. If you have an enhanced street sweeping program, you would support every opportunity to repave streets and bring those streets from poor to good. In fact, if streets were all at good pavement condition, the water quality improvement would be significant. I've said this for decades. I wish someone would hear this in the pavement industry and would say, okay, let's prove it. And we would prove it. Therefore, understand that street dirt accumulates within just a few feet of curbs or barriers. So if you have an expensive operation, and these are expensive operations with expensive equipment, don't sweep uncurbed streets. That makes no sense. That's a poor allocation of your resource. So do not regularly sweep uncurbed streets. Instead, occasionally sweep them, especially after a storm event where maybe a lot of debris and materials come down. So let's talk about the next item on the list, which is a series of, streeper type. This is very, very important. You know, I've been talking about mechanical broom and all these air machines, but broom sweepers employ a main broom that tosses the debris into a conveyor belt. Now, don't confuse the main broom with the gutter brooms found on all street sweepers. Mechanical broom usage used to be, should be limited to highways where there's no curves, but there's an accumulation, as well as conditions under heavier normal accumulation. In other words, I'm talking about following large storms and during spring cleanup. Mechanical broom sweepers need to go away. They're not the solution for reducing the quality of, or improving the quality of stormwater. Vacuum sweepers, they're excellent for, especially for porous pavements. Don't use a regenerative air. Use a vacuum sweeper if you have those kinds of pavements. But understand vacuums continually exhaust used air, so that can have a negative air quality impact. Regenerative air machines are recommended for enhanced sweeping program. Unlike vacuum machines, a regenerative air machine constantly recirculates or regenerates its air supply. And you know what? Just for fun, I've thrown a fourth one out there. This one doesn't exist. Believe me, there's been a few attempts at it and they haven't gone well, but they demonstrate that they can be done. So it's a matter of time. What I'm calling high efficiency sweepers, or HEES. What is a HEES? Well, it's a high efficiency sweeper, one that can pick up a very high percentage of the fine contaminants, but also employs a fugitive dust control mechanism, and also it has low maintenance costs, which has been the difficulty so far. We've got those kinds of machines that have created, but the maintenance aspect was very significant. So we think that this is the future vision for the street sweeping industry, and it's the public, it's the industry I'm hoping communicating with today that can drive that to occur and to force our manufacturers to start recognizing that watching a machine go down the street in a cloud of dust is probably the biggest negative that we're hearing about from the public. Change that perception, and you will change the perception of street sweeping. So let's moving on and talk a little bit about other things that are important. I want to make sure I get this done in a reasonable time frame. Okay, maintenance of equipment. I mean, this is a no-brainer, but it's amazing how many operations throughout the country, they'll say, oh God, those gutter brooms are so expensive. Can't we go another month or so with them? That's the number one problem. You've got to replace worn gutter brooms. They're very important in the process, whether it's a mechanical or an air machine. You got to maintain the vehicle, make sure the oil changed and the moving parts are functional and that sort of thing. So there is something called a tandem operation that I studied back in the early 90s at the city of Portland, in which we actually had a mechanical sweeper followed immediately by an air machine. They had one of the first regenerative airs that was available. Atemco, of course, created that technology. And and we saw dramatically better results. In fact, in certain circumstances, this might be the way to go, especially if you're trying to respond to a toxic spill, dry toxic spill. The other thing that's really important to know about is the forward speed of the sweeper. Now, the manufacturer will recommend 3 to 6 miles per hour, especially for heavy accumulations. However, speeds up to 8 and 10, we have shown only reduce pickup performance by 10 or 15%. So when you realize that you can go twice as fast and only lose 15%, what you end up doing in a given day is sweeping more street miles and removing more pollutants. So I'm not a stickler about forward speed, but please don't exceed 10. And when the accumulation is heavy, and your operators know this, these guys are smart, they're going to slow down to make sure they do a good job. Frequency, extremely important. I developed a computer model that could optimize that frequency for you if you invested in collecting some street dirt and other data. But the bottom line is that what we're finding is that common schedules are weekly, bi-monthly, or monthly. And more frequent sweeping should occur on streets with higher dirt accumulations, like high traffic areas, more major arterials with curbs. Now, here's the thing, folks. Daily or bi-weekly sweeping in downtown areas is a waste of your money and a waste of your time. Get some at-risk use to go around and sweep it up with brooms and buckets, because that's going to be far more cost effective. We do not need to do that level of sweeping with this expensive equipment. And that's what I'm saying, is allocate it right. Now, the last item on here is perhaps the most important, and that's, I have to make this very clear. The mandatory removal of parked vehicles is the most essential thing that we need to do for an enhanced sweeping program. And this can increase up your pickup performance by 30 to 60% compared to what the intensity of parking is on that street. But keep in mind that one vehicle blocks 3 car lengths, assuming you have an operator that's skilled enough not to worry about clipping side view mirrors. Takes 1 car length to get out, 1 to pass it, and 1 to get back to the curb. So put me 2 car lengths apart, and what is that? That's 6 car lengths that you're missing. Put a bunch of cars on the street scattered out, and you'll miss the whole street. So here's the thing. We know this is difficult, and we know it's a problem. Ranger's going to address it at some length with ideas of how we can make it more user-friendly. But you have to have a mandatory program, and you have to ticket. You have to get fines. And even if you do a great job of informing the public, as Ranger's going to talk about, those fines are going to be a significant amount of money, and they're going to help offset your cost. I'm not saying that's why you do it. I'm just saying that's going to be the results of doing it. So let's go forward and talk a little bit about, let's talk about some of the techniques that are available to basically identify what's going on in your communities in terms of street dirt accumulation. The street dirt accumulation model, there's a lot of information in this slide. I'm not going to touch on all of it. A lot of information on all of these slides, and we put it there so that you have a resource to go back to. But Dr. Robert Pitt, my good friend and University of Alabama professor, he taught me how to pick up street dirt back in the early 1980s in the city of Reno, Nevada. But basically the process is the same. You use a shop vac with a stainless steel drum because you don't want to contaminate the material you're picking up, and metals are really important for you to usually analyze. You got a portable electric generator, and you can suck up all the accumulated street dirt on any given place you want to go. And you know what? When we get this data, we can then understand the relationship between this accumulation and things like land use, street traffic volume, which is extremely important, and those street pavement conditions. The rougher the street, the higher the accumulation, and the more difficulty it is for the sweeper to sweep it. So by the way, when you get those fair streets, make sure you tar all the cracks. That's should be your go-to thing at some point before you can get it repaved. So in any case, what we do is we collect this information, this street dirt, and then we sieve it into a set number of sieves. There's basically 8 of them. And then we can composite that maybe back into 3 because chemical analysis is a lot more expensive. And we can analyze it chemically. We can find out what's in there. Ranger and I are now involved in a project where they're going to start looking at street dirt and figuring out what microplastics exist in each of the fractions. And then we're going to demonstrate, as I think we will, that street sweeping can be also very effective in that. I do want to mention that following me is a presentation, as I said before, by Larry Walker and Associates. They're going to go into details in all 3 of these things. That's why I'm touching on them. Now, the next one that we need to talk about is what in situ, or basically street sweeper pickup performance monitoring. Now, this is not testing. That's next. This is performance monitoring. And what that does is essentially you go out there and collect street dirt, but time it so that you sample a street that is not swept, and then a street sweeper comes along and then you sample it, not in the same place, but you sample one that is. So by doing that, you can actually get a handle on what your existing operation, what effect it's having on the street dirt itself. And this has been done, and I've listed the studies. By the way, if you need a reference, I didn't put a reference list together. Just let me know. I can get you that. So really, I mean, what they're going to talk about next is as an enhanced sweeping pilot, one of the 2 case studies they did for the cities of Burbank and Glendale, California. I was a sub to them, and it was a very, very fun effort. Now, let's talk about the one that probably matters the most, and this is controlled street sweeper pickup performance testing. And we want to use a precise approach. We want to establish a curb test area. Usually about 50 feet is what I've used and what others have used as well. We know the length and we know the initial loading. Well, how do we know the initial loading? Because we created a silica-based simulant whose particle size distribution closely matches that of the local jurisdiction that we're testing in. And then what do? Well, we put a certain amount of this material down with like a fertilizer spreader within a couple of feet of the curb. And then we have a time sweeping operation with a stopwatch. We decide, do we use water or not water? How fast should we go? And maybe we look at different pavement types. But, for the testing of new sweepers, let's cut them a break and give them good pavement, because that's really what they're designed for. Now, following that pass, we immediately vacuum the entire area, and we now have a before and an after. I developed this test in the mid-1990s. I've conducted it 6, 7 times in at least 5 cities in this country and internationally in Tel Aviv, Israel. So we can therefore determine how effective that sweeper, that model, and that circumstance is in picking up all the different ranges of the particle sizes that it encounters. And why do we want to do this? Obviously, we want to do this to identify those that are most effective in picking up the small particles. There's a recent effort that was done in the city of Los Angeles. Once again, that'll be covered in the next hour by John Ball, the city of Los Angeles, along with Larry Walker and Associates. So moving on, let's just summarize. What are the plus and minus aspects of sweeping? Okay, here's the disadvantages. The cost of the sweeper is expensive. Yeah, $300,000 a machine. Maintaining these, expensive. Gutter brooms aren't cheap. There's a resistance to citizens for, I got to remove my vehicle again. I mean, every 2 weeks, I got to move the vehicle. And basically, we can't operate during rain, which we shouldn't anyways. But in freezing weather, we can't operate because we're using water for dust suppression and it freezes. Why? Why, when it really comes down to it, is street sweeping far outweighs any other BMP we can do. We have no real estate. We have no property ownership. It's public property. We have no infrastructure to develop or maintain, and we don't have to go out and clean structures and maintain those. Sweeping is the most cost effective, and it costs the least. Now, that pretty much ends my presentation. I want to talk a little bit about who's going to follow me. Well, okay, there's a couple of things here. I forget this slide. You can read through them. I've created a computer model. Most people don't want to use it. I don't think they want to know the answers they get. But the fact of the matter is, we can model this. We have modeled this. Here's a good tip. Take the sweeping program out of streets and give it to the stormwater people. They'll be able to manage it much more effectively with water quality in mind. And keep in mind, broom sweepers are not as efficient at small micro pickup. They're more than they ever have been, but they're still not as good as an air machine. Vacuum sweepers, that's a good choice, but only for really porous pavements. Regenerative air is the best for general street sweeping. So keep those items in mind. So now I want to talk to you a little bit about my colleague, Ranger Kidwell Ross, who's also going to talk in this presentation. So moving your street sweeping program out of the past and into a cost-effective future of increased value. This is what he's going to talk about. Ranger is the founder and editor of worldsweeper.com, as he mentioned before. He's the most prolific writer and researcher on the topic of power sweeping. I hope I'm the second most prolific, but I don't think I'm even close to the articles that Ranger has researched and written on this topic. And his webpage is just a mechanism of information that's available at your fingerprints. And he's going to talk about the decision-making of stormwater and public works professionals so they can improve and enhance their street sweeping program. Take it away, Ranger.
Well, I'd be glad to, Roger. And as always, you did a great job. I want to touch it just for a moment on the mechanical broom sweepers. Yes, we do need mechanical broom sweepers for some construction cleanup. We need it for when they do paving operations and that sort of thing. Spring cleanup, yes. But if you need them for spring cleanup, don't make the mistake of continuing to use them throughout the year, because that is not going to help your stormwater runoff whatsoever. So I'm going to talk about, first off, what we can do to change things and some things that are technically possible right now today, as an example. One thing we can do is we can make sweepers the eyes of your community. They're out there, they're on regular routes, and with cameras, and especially now that we can enhance that with AI equipment, you can have a data collection, as Oregon City, for example, has done, that has a camera that can spot potholes, it can spot low limbs, it can spot down signs. You teach it what you want it to learn, and then you could have a keypad like you see here, and your operator, or automatically, probably now with AI, the information is sent to the correct department that you have assigned to fixing those kind of problems. I also want to encourage you to graphic up your sweeper, make it very environmentally pleasing. It can send a message along with, and the way I like to see those done a lot of times is with kids, have contests for them to design the graphics for your sweeper. And really educating your residents, as that last bullet talks about, Let them know about the value of sweeping. Yes, for them, they have to move their cars. And as Roger said, it's very important that they move their cars because we lose so much when cars aren't moved, and often the same cars are not moved, sweep after sweep. And so you can really get to some health issues there. But make sure your residents know how much value sweeping brings them. And the more you educate them, the less citizen friction you'll have. Educate them about the pollutant removal value of sweeping. You can do that at touch-a-truck events, which a lot of municipalities now do once a year, sometimes twice. They bring in a variety of equipment that they use in the city and let kids crawl all over them, and also have handouts and so forth to teach them. I encourage you to develop educational modules that go into the schools. Fifth grade is a great time to start doing that and bring home to the kids the environmental value of sweeping. Naming contests are all over the place these days, and they have really fun entries that especially kids will bring. Surf sweep a lot, and there's some great ones out there. So let's talk about this a little bit more because it's so important. The one vehicle equals 3 car lengths problem. You have to, with the sweeper, you have to pull out a car length before a parked car. You can't get in faster than a car length after the parked car. And if you have multiple parked cars in a block, that street is basically going to stay unswept. And the longer that can happen, it not only looks bad, it can be safety issues, depending on what's accumulating, can certainly be health issues, unquestionably, when the same areas of streets have not been swept week after week and time after time, and now you can get rodent problems and so forth. So it's so important to move vehicles. And one other topic I want to really touch on is we've talked about the small micron debris and how important that is. And keep in mind that 250 microns and now microplastics more and more are coming to the fore. Your hair is maybe 70 to 100 microns wide. So 250 microns, we're just talking about maybe 2 or 3 times as wide as your hair. Very small stuff. Don't lose track of the amount of material that is just out there. And Dr. Sansalone, that we have covered in the University of Florida and the Florida Stormwater Association test, read that. And I'm, like Roger said with one of the quotes, I'm going to read it because it's so important. With conventional best management practices, particulate matter removal costs dollars per pound. We're talking about just general debris off the street, anywhere from $4 to $41. For street sweeping, the cost of removing a pound of particulate matter is 10 cents. So there's really a strong value in sweeping, even considering getting the general debris off the streets. Now, let's talk about how you can develop a citizen-friendly car removal program. We have technological advances that have allowed that to occur. You can develop an internet app that would take your GPS program that's being used by most every street sweeping program in the country to keep track of your sweepers, and link that to your GIS system. Use an app to do that, and use this to provide alerts to your whoever owns a vehicle that lives on that street sweeping route. You want them to be able to have pull down menus to choose what they'd like to know about the sweeping that's coming up, let's say tomorrow. So, for example, they might want to have a notice the day before sweeping. They might want their next notice to be when the sweeper's a mile away. That allows them, if they are home, to bundle the kids in the car and go off and go shopping, or even wait and drive around the block and repark. Why can they do that? Well, they can do that because you are clever enough and technological enough to put a camera on your sweeper. That's another way to lower the cost of sweeping, because you can eliminate ticketing by your parking enforcement folks. The camera on the sweeper can, just like they do on toll roads today, they take a picture of any license plate that's in the way. That can be transmitted to your ticketing system, automatically can send a ticket to those folks, and you know they were in the way, because otherwise the street sweeper wouldn't have been able to take a picture of their license. And then let your citizens repark. You'll have a lot less resistance to your sweeping program and vehicle removal program if they're not concerned about having to move their cars for 4 hours. So that's just a real improvement in what technology can do. And you will find that the tickets will still pay a significant portion of your sweeping program. And that's an important aspect too. You'd like for everybody to move their cars. The matter of fact is they won't. So to ensure that you get a best management practice outcome, here's what you need in your car removal program. Set up a system through an app that will remind them when they need to move their car. Make sure that you have, as part of your system, and this is something that I see in the, I get a synthesis of street sweeping, where the word street sweeping appears every day via Google. And one of the big complaints that I see, or perhaps the biggest, is that they moved their cars and the sweeper didn't come by. Not a good thing. So make sure that your app includes that. Provide them another notice so that when the sweeper GPS says they've gone by their address, so they know they can move their car. And make sure they don't get a ticket if they move their car correctly and they weren't sitting there when the sweeper came by. So to recap, when you put together an enhanced and high quality sweeping program, educate your citizens to eliminate or really minimize the pushback that you're going to get. Include a real-time notification for changes. Allow immediate reparking, and coordinate your tickets with sweepers somehow, not a 4-hour window. Ideally, use sweeper-mounted cameras. This is available for you to do this. And if you have, as it says, extra credit, use a system to be the eyes of the community. You can make sure that you get a heads up on potholes and signs that are down and overhanging branches and that sort of thing. That will save you money. I know some number of cities employ a pickup truck that goes around, say, every 6 months or every 3 months, and goes to every street in the city and looks for things like potholes and low hanging branches and so forth. But it's much better. Your sweeper goes much more often than that. And the earlier you address these kinds of issues, by far the better. So it allows, if you have an AI software on your sweeper, you'll reduce the cost. You don't have to have the pickup truck going around anymore. And you'll get on these projects when it's really the most cost effective to fix them. Now, this other extra credit bullet: work to enact regulations in your state to credit street sweeping for pollutant removal. Both Florida is doing that, and Minnesota is moving in that direction based on these studies that are showing how cost effective it is to remove the pollutants that are targeted by their stormwater teams. They are saying, we want to encourage you to do more street sweeping, so we will give you credits back, basically money back to the city, based on the amount of material you take to the dump and or transfer station or wherever you're taking it, and eliminate. So that's a good way to make there be a credit. It also is a real incentive. So let's talk about, let's move into the future. And it's actually happening now, but it's also will have a lot of impact here in the future. Sea Grant, through the University of Southern California Sea Grant organization, but the overriding organization is NOAA, and with the city of Santa Barbara is where we're targeting in. We are part of a microplastics, both Roger and I, microplastics study, and what our part of it is going to be to develop a sweeping test that we find out what sweepers and makes and models will do the best job, because that gives you, the stormwater professionals, the street sweeping professionals, a better idea of what sweepers you should be buying, rather than the same old, same old. So with these different people that you see their logos there, we will be developing a testing process that will include air sweepers, mechanical broom sweepers, and likely vacuum sweepers. So what is really spurring this is that we need a sweeper test now that is designed to let buyers know what sweepers best suit their needs. As you see, the first, the top set of logos, this recent LA study that you're going to learn more about in the next seminar here, showed a pickup capacity for a broom sweeper, happened to be an Elgin Broom Bear, of only 35% of this basically smaller simulant that was put down on the roads. You can learn all about that in the next seminar. But the air sweeper picked up 75%. I wrote about this last month in my monthly newsletter, which I encourage everyone to sign up for. You'll find at the end of our presentation how to do that. And that was very important. Florida's study showed that sweeping is, 1.5 times more cost effective for a pound of nitrogen, 6 times more cost effective to pick up a pound of phosphorus. That's important. So which sweepers are best? They didn't segregate out between air sweepers and broom sweepers. So in that sense, we kind of don't know how to do that. The same thing happened with Minnesota. If only either one of these had called me and said, we're going to do a test, do you have any ideas that'll help? I would have said, yes, be sure that you segregate out who is using a broom sweeper with the data, who's using an air sweeper with the data. That didn't occur. So we'll be developing a test that takes all that into consideration. The only test that's currently out there was a decade or so ago, and it was the South Coast Air Quality Management District. They were more interested in air quality than stormwater runoff, and they didn't. They had it be pass-fail. So every sweeper that's ever tested, the manufacturers did things like put extra nozzles into the sweeper hoppers and so forth for dust suppression, and passed the test. So now there's no way for new sweepers to be able to test their sweepers, and we want to make that happen. And we know now that all current sweepers are using water for dust suppression. We also know that we're losing 20% of small micron debris when that happens. We hope the manufacturers can come up with something there. And I asked AI to tell me how many gallons of water it thought were polluted by sweepers every day. And the answer was 3 million gallons. They take perfectly good drinking water, put them into the sweeper tank, spray them out as the sweeper sweeps along the street, sucks it back in, and then trundles it off to the dump site as polluted water. And because they're doing that, we don't get as much small micron debris. We hope we can change that. The test that we have for Sea Grant and microplastics, we're in the stage of developing that right now. And we want to work with sweeper manufacturers. I'll be contacting all of them to get on a board, have a representative, and to help develop this sweeper test so that it can be the best possible test we can come up with, one that people can agree with. We need it to not only not be pass-fail, but we need it to show what percentage of the different sieve micron areas that particular sweeper was able to pick up, so that if you as stormwater managers and sweeping program managers have targets of different size materials and so forth that you want to be picked up, you can see where each of these sweepers rates in terms of what you're after to look at. And keep in mind, we're also interested in general trash pickup. These sweepers have to pick up the larger material as well, and we'll have a retesting process so that each manufacturer has a price they know to retest their sweeper, or new makes and models they can retest, and then we can keep this current as we go along. So that basically concludes my presentation on this and our presentation on it. We have, Roger and I have, if you can tell by the color of our beards, we've been around this a long time. And I have a newsletter every month that I put out monthly for 19 years through the worldsweeper.com website. And I'm also director of the World Sweeping Association. So if you're contractors out there and want to be involved with an organization that educates, that's the World Sweeping Organization. If you're doing just street sweeping and you want to be involved in knowing what the latest studies are and what's happening in this aspect of the industry, then I encourage you to sign up for our guest book at World Sweeper, and we'll do our best to keep you apprised of what's going on. And for this slide deck, I'm putting in, you can see the address to go to there, and we'll have that online. In fact, do have already, so that you can access it anytime you'd like. And from that point on, I think we're looking at questions, if we have any of those.
Yes, we have some questions. So I'll read off the first one that came in. For sweepers that utilize water, what methods have you seen or used to separate the pollutants from the collected water so they can be disposed of properly?
Well, I could address that and Ranger will take a shot at it. Basically, I haven't seen anything. It's the water is put down and the sweeper sweeps the street. So the water goes in the hopper, keeps the, maybe it keeps the material moist so that it doesn't create a lot of fugitive dust when you open it up and dump it wherever you're going. But no one's even, you're not picking up the water separately. The only technology that knows how to do that is called captive hydrology, where you literally blow water down at a high speed and then suck it up. And the machine weighs hundreds of thousands of pounds and goes like 2 miles per hour. They do it a lot for airport and that sort of thing. So the answer is it's not happening. And
let me take a shot at that. One of the things we've learned is with you can do separation or sifting when you get back to your site, and we see that when you sift out the large material and end up with small micron material, a pile of that, you can take a lot of times the small stuff to your dump site and use it for daily cover, which they a lot of times want 6 inches of daily cover. That allows you to take that out and usually dispose of it for free. But one of the things we found in a couple venues is that is approaching toxic levels, because you've taken out all the big stuff, and now you're only about 20% of your material on the street is 250 micron or less, but up to 60% of the pollutant load, total pollutant load we want to get rid of, can be in that small fraction. So
yeah, but you're talking about the solid fraction, and the question
that's
is
a solid fraction, and you have a water runoff fraction that's there. They usually make in the sifting operation, they make you contain all of that, and you can evaporate it, but that's about all I've seen anybody doing.
Okay. We have another question. Are there other effective or recommended strategies for public communication that does not heavily rely on real-time notification systems? This can be an obstacle for some municipalities with limited staff or resources, or an access issue for community members who do not have mobile phone or internet.
Well, that's a really good question. I just want to mention, and Ranger's probably going to jump on this one, is that as part of the project that Ranger and I focused on for microplastics, um, we are working with the University of Southern California, uh, or the University of California at Santa Barbara. We're not sure which one. And we're going to be working with a student class of students, and hopefully they're going to be able to design this app that we keep talking about. We've seen glimpses of this app. They exist throughout the country for various activities, but we want to create this thing, would be public information, be publicly available. And so, yeah, for all of its functions, you'd have to have probably ESRI, GIS, velocity module working, and that way you can actually know where the sweeper's going instead of just seeing where the sweeper is. That we have that already. Chicago's had this for years. You can go online and see where the sweepers are, but it doesn't do you any good. You don't know where they're going. So anyways, anything else, Ranger? I mean, it's going to be difficult if you don't have internet capability.
We're in an electronic age, and for people that don't have a smartphone and don't have a computer access, which is fewer and fewer, that's going to be a difficult situation. They'll need, all I can think of are paper notices that go out. You do a mailing, say when your sweeping is, and tell them they can't be in front of the sweeper. They can pull in behind it, and that's as far as I know, all we can go at for that. And if anyone that are asking the questions has a good idea that we don't bring up, please send us an email or let us know what your idea is.
Okay, we have a couple more questions. I'm just trying to pick the last one because we're running out of time, and then I'll send you the chat so you guys can answer the rest of them over email. Let's see. We kind of touched on that one a little bit already, so I'm going to go to the next one. Follow up on the question of separation on pollutants from water. Do cities have biofiltration systems that they can use to treat the water? Studies have shown that treated water decreases the mortality of coho salmon.
Yeah, well, I'm aware of what the University of, the city of Portland has been doing. They had a wastewater treatment plant, an old wastewater treatment plant, and they basically bring in their street sweepings, and then they dump it on a pad, and that drains the water off, and then they pump that to a clarifier, and they use bioremediation. So that's the only real treatment I know of. And then, of course, what Ranger was saying, they deal with the solids and they dry those. And I think they've covered those pads so that they can operate when it, because they don't want to sweep when it's raining. But sometimes in Portland, you're sweeping and it starts raining, so things can get wet. So they want to keep it as dry as possible. But that's the only thing I'm aware of. It's something that can be done, really.
Right. You'd have to dump your sweepings and then capture the runoff and deal with it, however's best to do that.
Mm-hmm.
Awesome. And we're getting close to being out of time. So there are some questions that didn't get answered. I'll send that over to Roger and Ranger, and they can email you with an answer to your question. But this is part 1 of 3 street sweeping workshops. So be sure you check out the other 2. There's one starting in just about 2 minutes that is called a data-driven approach to enhance street sweeping for water quality. And then the following hour, there is measuring runoff water quality improvement from street sweeping in Southern California. So be sure to join both of those. And for all you techie people, I know we talked about AI here. If you are interested in AI, we are going to have AI help write a SWIP and see what they can do for stormwater. So that is going to be at noon Pacific time today with 2 of the national stormwater podcasts that are currently available. So head over to stormwaterawareness.org to see the rest of the workshops and to register for any that you might not already be registered for. So thank you, Ranger and Roger, for this presentation. It was fantastic and packed with a bunch of great information. And thank you to everyone who is attending.